What we have said so far about the representativeness of a sample, however, holds only under the fundamental assumption of random sampling. Random sampling means extracting the sample from the population, ensuring that each individual in the population has the same probability to be sampled. The aim is to minimize the sampling error, that is the difference in the characteristics of the sample compared to the population. Random sampling, however, requires having a list of all the individuals in the population, which is not always the case. Sometimes random sampling is performed through systematic sampling, that is, picking every nth element from the population list, where n is given by the ratio between the population and the sample size. For example, if we need to extract a sample of 100 individuals out of a population of 10,000, that is a sample of 1% of the population, we will pick one every 100 individuals. The first, 101st, 201st, 301st, and so on. A more sophisticated form of random sampling is stratified sampling. This means splitting the population in subgroups, such as, for example, small, medium, and large firms, and then sampling randomly from each group, proportionally to the group size. In this way, it is usually possible to further reduce the sampling error. However, this requires not only to have the full list of individuals in the population, but also to know how they are distributed within the groups. In the IPS project, each partner institution was required to perform a random sampling from a national database of firms, within the criteria adopted to define the target population. Once the sample of firms was extracted, partners could leverage on various sources to find the contact information of the desired respondent, who was defined as the purchasing manager of the firm. Useful resources for contact information include alumni databases, association memberships, LinkedIn, and so on. The alternative to random sampling is convenience sampling. This means sampling the individuals who are more easily reachable, for example, because they are known. For example, if we need to survey manufacturing firms and we use a list of alumni of Politecnico di Milano who work in manufacturing firms, we are performing a convenience sampling. This is a known probability method, since it is not random and does not provide any guarantee that the sample is representative of the entire population. It is instead highly likely that there will be some form of sampling bias. In our example, despite we are very proud of our alumni, we have no guarantee that the companies who employ graduates from Politecnico di Milano represent the entire population of manufacturing firms. Convenience sampling, therefore, does not allow to generalize results to the entire population, because the sample is not representative. This method is used when there is no better option available, for example, because the census of population is not available, or generalization is not required. Once we have designed our sample, we are ready to move to the next phase, that is survey administration.